Bismillahirrahmanirrahim. Dear students, class 11 and chapter number is 7. Lecture number 5050 and we are doing chapter number 7, chemical equilibrium according to reduced syllabus. You can see, you can download from the internet from the site of Federal Board FBISC. Applications of the chemical equilibrium, already I told you. There are 3 applications. So in the first application I told you that Q quotient is the concentration of the product divided by concentration of the reactant. The first is that if Q quotient is less than equilibrium constant. If the value of quotient is less than, already I will discuss, Q is less than the value of Kc. This is number 1. Then the reaction will go to the completion. The system must will shift to right side until the new chemical equilibrium is going to be attained, established. If the Q is greater than the value of Kc, we are talking about direction of reactions. Direction, first application I am telling you, I think we done in the previous lecture. Direction. Direction of reaction. So when the quotient Q is greater than the value of Kc, it indicates that less product or more reactants is needed to acquire the chemical equilibrium. Therefore, the system must shift to the left until the equilibrium is reached. So in this case, the shifting towards the left side. In the previous case, the shifting towards the right side. So if the quotient is equal to value of Kc, so the equilibrium will neither shift towards the right side nor will shift towards the left side. So it is going to be in the equilibrium state. No shift will occur. Dear students, I am going to give you a hint and you have to solve this numerical that where the chemical reaction is going to be shift. Kc value is given 7.8 example, 10 to the power minus 1, 6.0, 10 to the power minus 6, 1 at 500 degrees centigrade, 1 mole of nitrogen, 3 moles of hydrogen and 2 moles of ammonia are going to form an equilibrium. Concentration of hydrogen is given, concentration of nitrogen is given, concentration of ammonia is given. According to the formula, Q is equal, Q quotient is equal, concentration of products divided by concentration of reactants. Apply this formula, all concentrations are given. Products must be towards the numerator side and reactant must be towards the denominator side. After calculating this, you will calculate the value of Q1 into 10 raised to power minus 3. Plus 3. 1 into 10 raised to power 3 value of Q. And Kc value is given 6 into 10 raised to power minus 1. So definitely the Q is greater than that of the value of Kc. The chemical reaction must shift towards the left side until equilibrium is reached. You have to show this one, greater than value of Kc. There is a self-check, you have to solve yourself. Quotient, you have to calculate, concentrations are also given and value of Kc is also given. To please, you have to solve this self-check exercise, questions are included. Then there is another application, extent of chemical reaction. Extent. Number second application. Extent of chemical reaction. Dear student, extent of chemical reaction totally depend upon magnitude, the value of equilibrium constant. Magnitude of value of Kc. Magnitude value of Kc, again you have a 3.4 here. If the value of Kc is very large, the value of equilibrium constant is very large. Very large means given here 5.4 10 raised to power 18. 5.4 into 10 raised to power 18 at 25 degrees Celsius. Very large. If the value of Kc is very large, so you have here example of hydrogen and bromine to give hydrogen bromide. You have to calculate, this is a hydrogen in gaseous state, bromine in gaseous state, to give the 2 moles of hydrogen bromide. Kc is equal concentration of the products divided by concentration of the reactants. Suppose concentration of hydrogen, concentration of bromine is equal to 1 mole, and value of Kc is given 5.4 into 10 raised to power 18 at 25 degrees centigrade. So concentration of hydrogen bromide, this is the one, this is the one. So students, concentration of hydrogen bromide 5.4 into 10 raised to power 18, there is the value of Kc. Take the squaring both sides. After squaring both sides, you can get the concentration of hydrogen bromide is again very high, 2.32 10 raised to power 9. The value of the hydrogen bromide after taking the squaring both sides, so concentration of hydrogen bromide is still very high, 2.32 into 10 raised to power 9 moles. Again very high concentration you find. So what's the result? It means that concentration of hydrogen bromide is very high indeed as compared to the reactants. The equilibrium mixture will have mainly products. Mainly products means hydrogen bromide is much more present in the equilibrium, means totally conversion of reactants towards products. So at equilibrium the mixture will have mainly products. The large value of the equilibrium constant indicates that reactions goes virtually completion. The virtually completion taking place when the value of Kc is very large. Now second is that if the value of Kc is very small, magnitude of Kc we are talking about. Number 2 is value of Kc is very small, means about given here 1.0 into 10 to the power minus 30. Now you can imagine at 25 degrees Celsius, very small indeed. So students, nitrogen 1 mole gas, oxygen gas 1 mole, formation of nitric oxide 2 mole like this one. So you have to calculate the value of Kc is very small. This same procedure, Kc is equal to concentration of the products divided by concentration of reactants, and if concentration of reactants nitrogen and oxygen are 1 mole, then Kc is 1.0 into 10 to the power minus 30 concentration of nitric oxide, and 1 here and 1 also here. So it means that concentration of nitric oxide is equal to 1.0 into 10 to the power minus 30 at 25 degrees centigrade. After taking the squaring on both sides, this will be a 1.0 into 10 to the power again minus 9. Again very low. The concentration of the nitric oxide is a very small indeed, 10 to the power 15. Very low indeed. It indicates that the reaction has a very little tendency to move forward. It means these reactants have maximum concentration. Very little reaction goes to forward. That is why you can imagine in the air 78% nitrogen and 21% oxygen. The partial pressure is maintained with also other gases. We are taking the air from the atmosphere. So suppose these two gases react with each other, then concentration of nitrogen and oxygen will be going to be decreased. Then how we maintain this partial pressure? So there will be no existence. And other case, this nitric oxide is a highly toxic and it creates pollution in the air. And this is a second disadvantage for the living organisms. First of all, the cycle of oxygen and nitrogen cannot be maintained. And second case, that very toxic nitric oxide gas is going to be produced. So that's why there will be no existence for the human beings or living organisms on the earth. So they don't react. They are not going to be react with each other. So because of the value of equilibrium constant is a very small indeed. So the most concentration of nitrogen and oxygen is remain on the reactant side. Number third is, students, when the Kc is neither very small nor very large, means intermediate. Suppose the value of Kc is 0.36 at 25 degrees centigrade. Dinitrotetroxide and 2 moles of nitrogen dioxide. Kc is equal to concentration of nitrogen dioxide square divided by concentration of dinitrogen tetroxide, 0.36. Suppose concentration of dinitrogen tetroxide is 1, then after taking the squaring both sides, you will get the concentration of dinitrogen tetroxide is only 0.6 moles. 0.6 moles are there. So this indicates that the equilibrium ceases, neither forward nor reverse reaction goes to completion. Reaction is in the equilibrium. So dear students, these are the second application. We have the extent of the chemical reaction. The extent of the chemical reaction totally depends upon the magnitude, the value of equilibrium constant. So this self-check 7.8 is very simple. White phosphorus, you know white phosphorus, there are many allotropic forms of phosphorus, but two are very important. White phosphorus and red phosphorus. P4. Phosphorus is going to be a form of 4 atoms combination with each other. I am not going to explain the allotropic form. So P4, white phosphorus, very reactive in nature. Always we put in water, always we store in the water in the laboratory, because outside more than 30 degrees centigrade it bursts. It reacts with oxygen. So he said that the phosphorus 4 burst, react, explosive, fast chemical reaction to give phosphorus pentoxide. So when exposed in the air, it bursts into smoke and fumes, and large amount of heat is evolved. Predict the value of cases large and small. Definitely large, because going forward reaction. At the room temperature, the reaction goes to completion, bursting, exothermic reaction taking place. So this indicates that the value of Kc is a very large, very large. Now dear students, this topic is a very important. Factors affecting equilibrium. Factors affecting equilibrium. So, it is necessary to understand the factors that control the position of chemical equilibrium. Knowledge of such factors help industrial chemists to choose conditions which favor desired product as much as possible. So we can predict the effect of various factors. Number one is concentration. Number 2, pressure. Number 3, temperature. And there is also influence of catalyst. So, if there is an equilibrium system, you then in the grade 10, Le Chatelier's principle. Le Chatelier principle. According to Le Chatelier's principle, if a change is imposed on a system at equilibrium, when the system is at equilibrium, when we are going to change, impose change in concentration, change in pressure, change in temperature, in presence of catalyst or not present in the catalyst, when you impose a change on a system at equilibrium, the position of equilibrium will shift, means equilibrium will be disturbed. The equilibrium will be disturbed, shift in a direction which tends to reduce that change, is called Le Chatelier's principle. So first we have to explain the effect of change in concentration. Effect of change in concentration. Number one. So there is an equation given. I am going to explain according to this equation. Carbon dioxide gas plus hydrogen gas to form carbon monoxide gas and water vapors. This is the dear students, this system is at equilibrium. Means rate of forward and rate of reverse are equal. This is the equilibrium mixture in a closed container which contain 1 mole of carbon dioxide gas, 1 mole of hydrogen, 1 mole of carbon monoxide and 1 mole of water in the vapor form. So this is an already chemical equilibrium established. Now I am going to make a change. Suppose he said that now I am going to disturb. Suppose I am going to change, add more carbon dioxide gas. From the outside, I am going to add more carbon dioxide gas. So, dear students, according to Le Chatelier's principle, the chemical equilibrium will disturb by addition of more carbon dioxide gas in this system. No more equilibrium now. The previous equilibrium will be disturbed because concentration of carbon dioxide gas is going to be increased. When the concentration of carbon dioxide gas increases, it reacts with the hydrogen, and the more carbon monoxide and water are going to be formed, the equilibrium will shift towards the forward direction. The equilibrium will be shift towards the product side till new equilibrium is established with the new concentrations of the reactants as well as products, because you disturb it by addition of carbon dioxide gas. After addition of carbon dioxide gas, concentration is going to increase. So it reacts with the hydrogen to give more carbon monoxide and water, the concentration are going to be changed. Then the new equilibrium is going to be established with the new concentrations. So when we add on something on the reactant side, the chemical equilibrium must go to forward. The reaction will must go towards the forward. Now suppose if I am going to add, suppose more carbon monoxide add. On the product side, if I am going to add something, on the product side, I am going to add something, carbon monoxide, suppose I am going to add more in the equilibrium mixture, again the equilibrium is going to be disturbed. The concentration of carbon monoxide is going to be increased, and carbon monoxide further reacts with water, the shifting of equilibrium towards the reactant side, left side. the equilibrium must shift towards the reactant side, towards the left side, and new equilibrium will be established with the new concentrations. Same case, if I am going to remove from the reactant side, I am going to remove from the reactant, something is removed from the reactant side. So when I remove something from the reactant side, the concentration of reactant side is going to be decreased. Concentration of the reactant side is going to be decreased. So dear students, then these products, they again react with each other. So because according to Le Chatelier principle, the chemical equilibrium is going to be disturbed, the reaction must go towards the left side till new equilibrium is established. So when you remove something on the reactant side, the shifting of equilibrium towards the left or the reactant side will be placed. Then if you are remove something from the product side, you are removing carbon monoxide or water from the product side. So the concentration of product is going to be decreased again. Then these reactants, they combine with each other and the reaction will move towards the product side, towards right side, until the new equilibrium is going to be formed with the new concentrations according to Le Chatelier's principle. So dear students, in the conclusion that according to Le Chatelier's principle, if you are disturbing the chemical equilibrium by addition on the reactant side, by addition on the product side, removing from the reactant side, removing from the product side, the equilibrium position will be disturbed and the new equilibrium will be established with the new concentrations. So this is the very important how the chemical equilibrium's concentration is going to be affect on the chemical equilibrium position according to Le Chatelier's principle. Dear students, there is a numerical to solve the numerical here. Effect of change in concentration, there is a numerical. Moles of iodide chlorine, 1 mole of chlorine gas, homogeneous equilibrium, 1 mole of iodine in the gas state. The value of Kc, equilibrium constant, is 1.0 into 10 raised power minus 3 at 230 degree Celsius. This is at equilibrium, students. Now means rate of forward, rate of reverse are 100% equal, and the value of equilibrium constant is this, and we maintain the temperature 230. Now according to Le Chatelier's principle, he said that if 1 mole, 1 point, the concentration I am writing here, the concentration of the ICl is 1.6 moles, concentration of the iodine and chlorine 0.05 moles and 0.05 moles. When chemical equilibrium is established. Now he is saying that when you are going to disturb, one more is added here. So if I am going to add one more here, then I explain when I add on the reactant side, according to Fischer-Tropsch principle, the equilibrium is disturbed and it must move towards the product side and new concentration will be formed. New molar concentration when the new equilibrium is established. Now how we solve? Initial concentration. Initial concentration is a 1.6. Initial concentration is a 0.05 moles. Initial concentration is 0.05 moles. Now when you add 1.1 mole more, then this will be a 2.6 moles. 2.6 moles, then new equilibrium is going to be established when you disturb 1 mole more. Now it equal to 2.6. So dear students, when the 2.6 moles are going to form, so the reaction goes forward, means this will decrease. The concentration is decreased, that's why it goes the forward direction. So how much concentration decrease? We don't know. X. How many moles are here? 2. So 2.6 minus 2x. 2x moles of iodide chloride are going to be decreased. We don't know. We have to find the value of x. And reaction goes forward means 0.05 plus x and 0.05 plus x moles are going to be formed for the product side respectively. So the volume of the solution may be 2 liters divided by 2, it will no effect. It will no effect. 2 liters volume, no effect. So according to the law of mass action, concentration of products, concentration of reactants, then value of Kc you know. Kc value is 1.0 10 raised to power minus 3. Concentration of the chlorine 0.05 plus x 0.05 plus x and 2.6 minus 2x. So dear students, they are both same, so we make it a square. So 1.0 10 raised to power minus 3, 0.05 plus x square, 2.6 minus 2x also square. So under root, taking the squaring both sides, you will get volume is going to be cancelled, dear students. Volume cancelled. So when you take under root for this, so you will get 3.1 into 10 raised to power minus 2. 3.1 into 10 raised to power minus 2, and this will be 0.05 plus x, and this will be a 2.6 minus 2x. You have to do yourself, खुद भी करें अंडर ले लें इसका. Then mathematically you know this will be multiplied by this will be multiplied by this, and after calculation you will get the value of x. The value of x will be is equal to 0.029 moles per decimeter cube. After calculation, you will get this value. You have to calculate very means precisely. Now here student, now you have the value of x. This is going to be the value of x. So here 2.6 minus 2x means 2 multiplied by 0.029. Then you will be able to calculate the value of the ICL. After calculation, this will be 2.571. This will be concentration of ICL. This is 2.571 instead of 2.6. Then you have to add 0.05 plus 0.029 also here, 0.05 plus 0.029. Then the concentration of the chlorine and concentration of the iodine both are equal, and after addition you will get 0.079 moles per decimeter cube. So dear students, according to the Nash-Pierce principle, after addition of 1 mole from 1.6 changes to 2.6, the chemical equilibrium will shift towards the forward direction, and after calculating the value of x, so from the 2.6 changes to 2.571 moles, and it is going to be decreased because new equilibrium is going to be established, because the concentration of the chlorine was 0.05 and iodine also 0.05, so it is going to be increased from 0.5 to 0.079 because new equilibrium is established. So this is the disturbance when you add and when you remove. Self-check exercises is that when you remove 1 mole, calculate yourself. This is the homework assignment. Self-check 7.9, here is that equation is same. Read carefully. In the last, we remove the 1 mole, means 1.6, you remove 1 mole, 0.6 only. What happens? So when you remove here, the concentration of the reactant is going to be decreased. So it means the chlorine and iodine, they react and goes to the backward, left side. So that we are going to finish here, students, and you have to do these numericals, and these are in the reduced syllabus there is present here. So please do this one. Thank you very much.